Chemical reactions. Analysis of the properties of substances before and after the substances interact.
Hello, Adam.
Hello, Alex.
What are you doing?
I'm trying to learn how a new substance is formed by reacting two or more substances.
Well, do you know that this procedure is known as a chemical reaction?
Will you please tell me some more about it?
Yes, sure.
Now let us learn what a chemical reaction is. Chemical reaction. It is defined as a process that transforms a set of chemical compounds to another through a chemical reaction. In general, a chemical reaction has a form like this. A and B are the chemical compounds which combine chemically to form C and D. This is known as a chemical reaction. Some of the reactions absorb energy, whereas some reactions emit energy along with the products. So we can divide chemical reactions into two parts. 1. Exothermic reactions. 2. Endothermic reactions. First, let's discuss the exothermic reactions. Those reactions which produce energy along with the products of a chemical reaction are called exothermic reactions. The general form of these reactions is as follows. Reactants give products plus energy. This energy can be in the form of heat, sound, or light. For example, the burning of sugar produces energy. C12H22O11 plus 12O2 gives 11H2O plus 12CO2. Also, the burning of coal produces heat. Next are the endothermic reactions. Those reactions which absorb energy along with the reactants of a chemical reaction are called endothermic reactions. The form of these reactions is as follows. Reactants plus energy gives products. This energy can be in the form of heat, sound, or light. For example, photosynthesis, that is, a chemical reaction in which plants convert light energy into chemical energy. The reaction is given as 6CO2 plus 6H2O plus energy in the form of sunlight gives C6H12O6 plus 6O2. There are also various properties of substances such as density, melting point, boiling point, solubility, flammability, and odor. These properties may change as the reactants change into products during a chemical reaction. Devices that either release or absorb thermal energy by chemical processes. As we all know that there are certain devices that either release or absorb thermal energy by chemical processes. Most of these devices are used by us in our daily life, such as a thermos flask, a lunchbox, a water bottle. These are the devices which keep the material inside, hot or cold, for a long duration of time by controlling the transfer of energy to the environment. Winter gloves keeps a person's hands warm in the winter by insulating the hands from the environment. A hot cup of tea without a lid releases energy in the environment and gets cold. Let us understand this concept with the help of examples. The first is dissolving ammonium chloride. Ammonium chloride is a white crystalline salt which is highly soluble in water. The chemical formula is NH4Cl. Uses of ammonium chloride. It is used in cough medicines. It is used as food additive, commonly as a yeast nutrient in bread making. It is used in baking cookies, giving them a crisp texture. It is used as a thickening agent in hair shampoo. It is also used in fertilizers. Since ammonium chloride is a water-soluble salt, as it dissolves in water, it breaks up into ions NH4 plus and Cl minus, and the reaction is given as NH4Cl in aqueous form, that is mixed with water gives ions NH4 plus Cl minus. Note, this reaction is an endothermic reaction, as the liquid absorbs energy to dissolve ammonium chloride, so we can write the reaction as NH4Cl in aqueous form, that is mixed with water plus energy gives ions NH4 plus Cl minus. The second is dissolving calcium chloride. Calcium chloride is calcium and chlorine salt which is water soluble. The chemical formula is CaCl2. Uses of calcium chloride. It is used for de-icing the roads during snowfalls. It is used to increase the hardness of water. It is a source of calcium. It is used in canned vegetables. It is used to maintain textures of sliced apples. Since calcium chloride is water-soluble salt, it dissolves in water to form calcium oxide and hydrochloric acid, and the reaction is given as CaCl2 plus H2O gives CaO plus 2HCl. Note, this reaction is an exothermic reaction as it releases energy, so we can write the reaction as CaCl2 plus H2O gives CaO plus 2HCl plus energy. Factors which affect the rate of a chemical reaction. The first factor is the temperature. On increasing the temperature, the rate of a chemical reaction increases and vice versa. For example, cooking takes less time when we increase the intensity of the burner stove. The second factor is the concentration of the substance. On increasing concentration, sometimes the rate of a reaction increases while sometimes it decreases. For example, in any reaction, if we increase the acid amount, the rate of the reaction increases, while if we increase the amount of the reactants, that is, the concentration of the reactants, keeping the acid amount the same, then the rate of the reaction decreases as the reaction will take more time to complete. Total number of atoms and mass remain conserved in a chemical reaction. Law of conservation of matter. According to this law, matter can neither be created nor be destroyed during a chemical reaction. This means that the mass of the reactants must be equal to the mass of the products formed in a chemical reaction. Also, the number of atoms present in any molecule remains conserved during a chemical reaction. For example, a piece of clay weighs 5 grams. We divide it into 4 pieces. 2 of them weigh 1 gram each, and another 2 weighs 1.5 grams each. That is, 5 grams is equal to 1 gram plus 1 gram plus 1.5 grams plus 1.5 gram. Thus, the weight of clay before and after remains the same, which is in accordance with the law of conservation of matter. Now, let us understand the above concept with the help of examples. The first example is the burning of sugar. When we burn sugar, a chemical reaction takes place in which sugar reacts with oxygen and forms water and carbon dioxide. The reaction is given as C12H22O11 plus 12O2 gives 11H2O plus 12CO2. Now let us see whether this equation follows the law of conservation of matter or not. Thus it is proved that the law of conservation of matter holds good for this equation. Now we will try to know whether this equation is balanced or not. For this we will check the number of atoms of H, C, O on both the sides of the equation, as in LHS we can see that there are 12 carbon atoms, 22 hydrogen atoms, 35. That is 11 plus 12 into 2 oxygen atoms. In RHS, we can see that there are 22, that is 11 into 2 hydrogen atoms, 35, that is 11 plus 12 into 2 oxygen atoms, 12 carbon atoms. Thus both sides of the equation have an equal number of atoms of all types, and we can say that this equation is balanced. The second is the burning of steel wool. Steel wool is an arrangement of very fine, soft steel filaments in the form of a bundle. While burning steel wool, electricity from the applied battery runs through the steel wool and heats it up. The heat accelerates the reaction between the iron of steel wool and the oxygen in the air, and thus the steel wool catches fire. The chemical reaction taking place in burning steel wool is as follows: 4 Fe in solid state plus 3 O2 in a gaseous state reacts and gives 2 Fe2O3 in the solid state. This equation is balanced as the LHS has 4 Fe atoms, 6, that is 3 into 2 O atoms, and the RHS has 4, that is 2 into 2 Fe atoms, 6, that is 2 into 3 O atoms. Now let's see whether this equation follows the law of conservation of matter or not. As we can see that the law of conservation of matter holds good for this equation. The third example is zinc reacting with hydrogen chloride. In this chemical reaction, zinc reacts with hydrochloric acid, resulting in the liberation of hydrogen gas and formation of zinc chloride. The reaction is given as Zn plus 2HCl gives ZnCl2 plus H2. This equation is balanced as LHS has 1 Zn atom, 2 H atoms, and 2 Cl atoms, and RHS has 1 Zn atom, 2 Cl atoms, and 2 H atoms. Now let's see whether this equation follows the law of conservation of matter or not. As we can see that the law of conservation of matter holds good for this equation.